function. The function that will give us the instantaneous rate of change of this at any point where the function is differentiable, where the function has a derivative. So I have to write the limit as h approaches 0 from f of x plus h minus f of x divided by h. Good. So f of x plus h. Very simple. We have to determine that. F of x plus h. Flavi, this is not your class. The link will be sent in an email, please, before 8:30. It's not your class. It's a token of respect. I allowed you to come in, but it's not your class.
Okay.
So I will email you the link before 8:30. I promise.
Okay, thank you.
Thank you. So can anyone determine f of x plus h for us? I have to copy 1/2, then parentheses. What will I copy next?
X plus h.
Of course. Thank you very much. And then minus 3. Good. All I have to do is plug them in, put h in the denominator, and apply the limit. And it's done. I hate not to answer and just remove students without at least explaining. I didn't remove her, of course. Limit. So my apologies for you. So I replace 1/2 x plus 1/2 h. I distributed minus 3 minus 1/2 x and plus 3. Remember, we have to distribute the negative sign divided by h. Now remember, we discussed this. What has to happen here? First step. All terms without h must go away from the top. We discussed that 2 weeks ago. Then h from the denominator has to cancel out. That's step number 2. So I'm going to copy limit as h approaches 0. 1/2 h divided by h, yes. And that happens too. Now remember, the limit operator does not disappear. You cannot drop the limit operator till the last step. Can anyone give us the answer? Say it again, Tariq. I couldn't hear you.
I'm sorry, say that question one more time.
Yes, I'm applying the limit of this function when h approaches 0. What will the limit be? I thought you wanted to say something.
I'm not sure.
But this is a polynomial. So how did we find the limit of a polynomial?
Did we plug it back into f of x?
No, 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 no. All that is done. It's gone. We're done with that. I need to determine the limit of this constant when h approaches 0.
It'd be 0?
But
Or
if,
it'd be 1/2?
that's it.
Yeah.
Plug in this function, plug in h. I don't have any h.
Yes.
So the limit of 1/2 when h approaches 0 is 1/2. So we knew that from the very beginning. What is the slope, which is the rate of change of this function? If you look at this, what is the slope?
1/2.
That's it. The rate of change of this function is a constant. It's 1/2. It's a linear function. So we already determined with the difference, with the limit of the difference quotient, we determined its derivative. This function is linear. Its derivative will always exist because the function is always differentiable. Thank you. It was a very good class. Thank you for your involvement in